Sure. So it's I get your point. A lot of repetitive jobs, it would go away. Of course, a lot of people do not have basically interest to do such a job if they do not have to. I see your points. Basically, there are a lot of benefits, but do you know as well the disadvantage of automation in a mass way?
So yeah, that's the risk is here, and I think it's up to us as society to find solution for those problems, and I think we always manage to find alternatives things to do. What is it called? General common income, like so that everyone get enough money to survive.
Yeah.
Then they have the rest of the time they can do whatever they want. It's one of the solutions proposed.
I would like to maybe a little bit talk about specifically robotics because there are different types of robots. Of course, you see humanoid robots. You see a lot of like dog-shaped robots. I mean, a lot of things that every day they get into the markets. And what do you think of that? So
So actually, one thing that disappointed me when I grew up and started to discover this industry, that I have been passionate about robotics since early stage, as I said. And then once I started looking in the manufacturing industries and about looking at those robots, I learned that most of them are just they are programmed using the stitching method. So basically, I do this one movement, and I tell the robot, please repeat this million times until I don't need this task anymore. Uh,
what exactly do you mean by simulation? Like, because
mhm.
what is the difference? Okay, this is the question. What is the difference between an offline programming simulation with a digital twin?
The digital twin doesn't have to be the 3D space with nice rendering and this nice power to call digital twin. Like if it's just like digital twin, it's just a digital representation of physical um,
Sure,
objects.
sure, it can also be.
So if I'm able to describe those objects using more simple way, and depending on the use case, it's actually a question that I also myself also ask my question, and I get challenged about this talking with my colleagues and the clients, is what is the value that brings me to bring this new other area of building digital twin.
Way. So imagine that you have an avatar. All right. So imagine that you have an avatar and you go in this digital twin world, like a digital version, and a humanoid robot represents you in the factory floor. So it is both ways. So it is like that you say that in digital world I have an avatar and in real world I have a humanoid robot that do the job, or the other way around. If anything happened in the real world, there should be a representative of that in the digital world. Somehow synchronize everything. What is the benefit of that? What is exactly does it mean? AI in digital twin. All right. Hi everyone. So welcome to this episode of DYM podcast. Today I have a very nice guest, Amine Kharrat, and I'm really happy to have him on my show. And Amine, welcome. I'm really happy to have you here. And please tell us about yourself, what you do, actually.
Yeah. Thank you, Nima. Thank you also for the invitation. Very excited about talk. Yeah, so short to me, I'm Amin. I'm one of the co-founders of Open Robotic Metaverse, which is an organization toward pushing the collaboration robotic space. And I'm a full-time consultant at Accenture Industry X, where I focus on digitalization in manufacturing. And I'm pushing innovative topics such as the use of, for example, Omniverse, which is platform to use build digital twin, and simulation for automation use cases in manufacturing, but also now the use of AI and generative AI in the manufacturing and how we can bring them in a productive way to the in manufacturing. So yeah, that's shortly to me. And I actually describe myself as someone curious. Yeah, always looking. I've been excited about automation since early age. So I first started with automation using those Arduino boards. So I was excited. Okay, how we can bring software to things that moves or that act. And I was very excited. It was in a fair I discovered this Arduino device that you can program and then can move things. So I yeah, one of the exciting projects I did it in school was to build a robot arm,
Hmm.
and yeah, that's where the journey started. And I since then I didn't quit the field. Yeah.
Yeah, sure. So I always say that it's always nice to do stuff to learn. So learning by doing is the best way to approach. But
Um, yeah, that's true. That's something I've been pushing all the time. So during school, I've been doing those Arduino projects. Then come to university, I always looked for jobs where I can do hands-on things, and I learned by doing this. And during the study, actually in early stage, I founded a non-profit organization. It's called elapse Aachen, and with the goal was to teach programming, but also we focus on data science and deep learning, a little bit of web development, but mainly data science and deep learning. And our approach was exactly to do projects and to encourage students who want to start in the field to do hands-on projects and learn while doing. And yeah, and I think also now most of the time when new technology came up, I say, okay, I will just install it and test it out, and that's the only way to learn
sure.
how to, you know.
So what did you exactly study in Aachen?
So I studied mechanical engineering.
Hmm.
It's one of the biggest fields in Aachen, so it's actually quite known for it.
Sure.
And I did my specialty in production engineering
Hmm.
with also more specialty on around automation.
Okay. So you're somehow focused on mechanical engineering, but like let's say robotic or automation is also one
Yeah.
minor part.
Um, so actually, I've been programming most of the time, like since school time. So also while was studying mechanical engineering, all the jobs that I've been working parallel to my study the whole time, and all of my jobs I was basically programming on doing automation tasks.
Mhm.
And yeah, that's actually yeah my motivation for robotics is actually yeah you have to have the basics of a lot of things like the three main subjects are mechanical, electrical, and programming. And yeah, so I did, yeah, I think I got good backgrounds in mechanical engineering and production,
Yeah,
which is I think it's the thing that open a lot of use cases. So you understand better the manufacturing, understand production, how things are being produced. And I bring those programming skills that I try to learn in parallel and try to solve use cases that are existing in the manufacturing. Yeah.
sure. I mean, like somehow multidisciplinary field, and it's everything is involved, right?
Um, yeah, actually, you never know which skill you need and the problem you are facing. So I actually also what I learned the most in university is to learn to solve problems or how
Mhm.
to think logically about problems. So whenever there is a problem, you try to abstract it, see it from different perspective, and depending if you need a skill from mechanical engineering, then I'm gonna have some of the backgrounds from university, but of course you have to dig deeper into more details into the problem. Or sometimes you need new skill, which is most of the time actually, and you just have to Google or try to learn these new skills in parallel. And now it's easier to learn new skills using those generative AI chatbots that you can do a lot of question answer until you really understand this new topic. You have to always prove double check the information you're learning. But yeah, I think that's how I face, we deal with those challenges. You always have to learn new skills and move forward. Yeah.
Sure. And may I ask what are you doing now? Like, what's your current activity?
So I'm part of a team called Agile Manufacturing and Smart Automation, which is part of Industry X. So this is basically we help manufacturing companies face like get digitalized.
Mhm.
So basically what we do, we go to companies who are excited to integrate, like to think about AI and to use the newest technology to improve their productivity, to reduce their their costs and so on and so forth. And we start with the basics, what they have. We do analysis about what the current state is, and we support them step by step how they get access to their data, to define which data they need to require, and and um, and support them until the implementation basically of those technologies. And being in a consulting job, so basically I participate in different projects depending on the mission. And yeah, and in parallel to this, I'm talk I try to convince people about the advantages of building digital twin of of their production, and try to find the value in this. Um, yeah, and I believe this will bring a lot of advantages for the manufacturing in general.
Sure, sure, absolutely. No, that's
Um,
a quite necessary field. I would say that all the industry needs to go this way to save cost and also increase the efficiency, especially for production and logistic. So nice. So I would say that would be nice if we go a little bit deeper and just a little bit more technical. So I mean, I would say that how do you see how do you see automation in general? How what do you think that automation or anyway like kind of digitalization can help us? Why there is a need of that?
yeah, sure. I think this is a big topic. I tend to debate about this with my friends when I'm outside. So I think the first motivation for, if you look at the current state, companies need to produce things, and they need employees to get things done. And most of the time they struggle to find the employees. So I think that's where automation can support. So basically, and I think this problem is getting bigger and bigger, especially in developed companies. So they struggle with finding the skilled labor to do tasks, and that's where automation can solve this labor problem. But at the same time, if we look at a lot of the tasks that workers have to do during, yeah, it's a lot of them are yeah, not very exciting tasks.
Yeah.
And I think this is where automation can free us from non-fun
Mm.
tasks, and so that we focus more on the more productive part of working, and also to free us from dangerous or boring tasks that no one wants to do. Yeah, and then the same time, what I think motivates me the most is once we can automate most of the tasks that we don't want to do or that are not very valuable. I think this opens a lot of opportunity. People will have a lot of time to use this time in things that they want to achieve, or they want to do. So looking like, if I zoom out, looking at society, if step by step we get more and more tasks automated, and hopefully we get to a point where we are so productive that we can maintain sustainable life for everyone, um, um, without, like, we need to work 40 hours a week for each one of us. I think we're gonna see a lot of diversity, more diversity in life, people coming with their own ideas or creativity. And I'm very excited. I hope we can manage to live that moment before we go away from life. But yeah, it's something that I think I'm very excited to see, yeah, diversity coming out of people who don't have to do jobs that they just have to do for surviving, basically.
Sure. So it's I get your point. A lot of repetitive jobs, it would go away. Of course, a lot of people do not have basically interest to do such a job if they do not have to. I see your points. Basically, there are a lot of benefits, but do you know as well the disadvantage of automation in a mass way? I mean, like in a way that um, a lot of jobs to be replaced. This. What do you think about this type and this part of the view, or from this perspective, that if most of the jobs that are related to automation somehow to be neglected or to be yeah, to be away from the scene. Um, do you have any
Yeah,
comments about that?
yeah. So yeah, that's the risk is here, and I think it's up to us as society to find solution for those problems. And I think we always manage to find alternatives, things to do, and we always have, yeah, we want to always to improve our lives in one way or another. So I believe that we always gonna have things to do. And if I look at the focus on automation, if I talk with people or we see people doing those repetitive jobs, but also not repetitive jobs, a lot of tasks that we just do them because we need the salary at the end of the month to be able to pay the bills and survive. And um, I think it's up to us, to society, how we can use more automation to produce enough goods and provide good life for everyone without them needing to do these boring jobs. Yeah, I think this is it's a big challenge. I think we cannot. Yeah, it's we have to do it in an iterative way. Probably we're gonna try different things. I think this uh, what is it called, general common income, like so that everyone get enough
Hmm.
money to survive.
Yeah,
Then they have the rest of the time they can do whatever they want. This is one of the solutions proposed. Uh, but I think we need to iterate and try different things and yeah.
sure.
And at the same time, yeah, yeah, um, I think we always need people. Like I think people brings the most of the things to the table, and we tend to like. I'm very excited about the diversity topic. So actually now the society is built around we go to study and learn skills that the society is built that we need those skills to fulfill specific tasks,
Mhm.
um, to produce goods or to clean street or to keep the society working. I think if we manage to get this done automatically, I think people will not be forced to study those things in that specific area to fulfill the society needs, which hopefully most of the society needs will be automated. I think people will start from early stage also have more freedom of thoughts, more freedom. Okay, what I want to do now with my time, what I want to create, and I think out of this a lot of new ideas and new way of living will come out.
Okay. Nice. Yeah, I see your point. You are positive about that. I would like to maybe a little bit talk about specifically robotics because there are different types of robots. Of course, you see humanoid robots. You see a lot of like dog-shaped robots. I mean, a lot of things that every day they get into the markets. And what do you think of that? So, are they just a little bit exaggerating, I would say, or do you think really there are some application like for specifically for robotic and how it can actually help us? Because there are some way of conventional automation that we have had for decades, like in the factory lines. But if you go specifically to robotics, you see from the industrial robotic arms which started from 1970, I guess, until now, a lot of changes have happened in the field of robotics. What specifically what's your comments about that?
So So actually, one thing that disappointed me when I grew up and started to discover this industry, that I have been passionate about robotics since early stage, as I said. And then once I started looking in the manufacturing industries and about looking at those robots, I learned that most of them are just they are programmed using the stitching method. So basically, I do this one movement, and I tell the robot, please repeat this million times until I don't need this task anymore. And this, yeah, it's actually disappointed me. I thought, okay, maybe we have more intelligence. I thought at early stage that the robots are more intelligent to react to changes happening in the environment. But I think this is now happening. I think more people like we're building more and more sensors, and we're trying to use the data we require from those sensors to make the robots interact with the changing environment. And I think yeah, we're going. I think this technology, and also this, like the first step is like to use sensor data to adapt to some changes, and then the second step is to add more intelligence. So we have really um, not adapting to pre-programmed cases. Like if the sensor detects like a part not in the location, inform employee. This is basically the adaptation using normal sensor, like that is happening now. And I think that where it is going, and there are a lot of companies are moving now, is about giving the robots the possibility to think and to adapt, to adapt to whatever task it is doing. And I think this will open also a lot of new opportunities. About I think we're gonna like I think this intelligence will make us capable of producing at specific products, so we don't have to produce the one product million time in order to be able to automate the process. I think this will make us able to automate processes even if we are producing if each part is different from the other part that we are producing. So this is the one part of this, like adding this adaptability in robotics. And at the same time, we see a lot of companies saying, okay, since we have this intelligence now, we need the robot to really be able to do more than one task that is specifically designed to do it. And that's where we see companies like going now in the direction of designing those humanoid robots, because they can do a lot of tasks and they can adapt. And they say like the thought about it is, hey, our world is built around humans, and humans can do a lot of things. So if you design a robot in the same shape of a human, probably robots are also gonna be able to do a lot of those diversity tasks, and then I can use the same robot that I do my investment in to fulfill different
I
tasks.
mean, we might have a little bit disagreement here that if we consider human as the most capable form of like, I mean, like imagine like the industrial robots could lift up to 900 kilograms. So there is no humanoid robot can actually do such a thing. So you have to also think about the application at the end. What is it going to do? Of course, like for doing some stuff, intelligent stuff, the way that we are going forward is nice. I like it. It's getting more complex, of course. A lot of sensors. It gets also as well maybe a little bit more expensive because we need to apply a lot of components, hardware, software, and anything. But look at the job that they need to do. So specifically, we do not necessarily to make everything complicated for such applications. So I understand your point of view to make to build something capable of doing a lot of multitasks things, or but necessarily you really need to if you can solve something with very conventional things, why you have to apply all those things like um, I hope that you understand what I'm trying to say.
Yeah. Actually, in reality, it's gonna be like you are describing. At the end, how our society works, we have companies that needs to make money, and they need to spend the less money as possible. At the end, they're gonna be okay. I need to find market for this product that I'm selling, and I have to produce it in the less cost possible.
Hmm.
So they're gonna design the production line, how to produce the things, and they're gonna choose the cheapest, more efficient way to do it. And if you do it now, probably the most efficient way is the traditional way. I think it's gonna still follow us also in the future.
Yeah.
But as we want more, I don't find the word, but basically those more. Like for example, each one can design his own shoe. So like the shoe company can produce a specific shoe for
Okay.
each person.
Hmm.
I think people will be able to have this, and there are gonna be companies who are gonna be able to produce a production line that is very adaptable, and they can adapt to whatever the changes are happening in the market.
Specifically, I
Um,
understand your
but
point.
it's gonna be a combination of both, and I think this traditional way of doing it is gonna still, yeah, this is, yeah, it's gonna follow us for long, yeah, maybe for always. So yeah, it's just an alternative, and it's open to new possibilities. And I think most of us don't even know what is possible with those alternatives.
Yeah.
So it's gonna just be prepared for for more innovation and more. I think people will probably think about yeah interesting ideas that they want to use those new technology to build.
Sure. All right. So I would say we will go to the third part. So I would like to know, why do we need simulation for automation? That's the part that I actually think that you are more expert, and you have worked, you have more experience. And I would like also to ask about what is actually digital twinning. It is very viral at the moment, and yeah, I would be happy to know your opinion about that.
Yeah. So maybe before we start with this, I want to share one of the projects that I worked with. I worked on
Sure.
in the industry, and then I will use it as a motivation to why we need a digital twin and why we need a simulation.
Sure.
So I will shortly share my screen and share about this manufacturing project. Okay, let me know once you see my screen.
Yes, sure.
Is it visible?
Yes, yes, I can see that. I don't know if it has
Okay.
voice or
So, so sadly, the quality is not the best, but
yeah,
basically what we see here, we see a robot arm
yeah.
that is depalletizing
Mhm.
parts in a manufacturing process. So this is a project I worked on, I think 3 or 4 years ago. And what we see here is we have a computer vision model, vision system here that is detecting the location of the part. And so this location that this computer vision detects will send to the robot, and the robot know basically uh, where to go and how to grasp the object in order to grasp it. And one of the things here very interesting about this project, those parts they are existing in multiple sizes. So we have a catalog of 400 parts, and the robot, like the gripper, was also has also be to designed in a way that it can grasp all those 400 parts, which are different sizes and different shapes. So the robot the gripper needs to adapt to those changes. And at the same time, we need like the way those parts were palletized is that we have a carton in between,
Mhm.
and the tax side was very important. So the two things. So in order we didn't want to use another gripper that we change when we need to take this carton away. So we needed to design this one gripper in a way that once it it depolletized the parts of one level, it just turn and take the carton away without losing time. And at the same time, to have still be in a higher tact side, we needed to um, we needed to reduce the trajectory that the robot needs to do. And that's why we come up with this idea of having this elevator. We call it elevator. So basically each level that the robot needs to depelletize come a little bit higher every time so that the robot don't have to go to the bottom to grasp the part. And it has been like we invested a lot of engineering in this solution, like a lot of work from design perspective, from the electronic perspective, and from the computer vision perspective. And it was very interesting. It was fun. I think all of us enjoyed this project. Um, but I think this is also open and like coming back after this project. Coming back to this project was done in Tunisia, Tunisian company. I'm really excited to see such projects happening in Tunisia. And when I come back, I start thinking, okay, how can we use this? How can we scale this solution? How like I'm very like what are other companies are doing at the moment? And I think it's actually also frustrated me that developed this solution. We were all of us, I think, three people of us are still in the beginning of their career, don't have a lot of experience. We had to invest a lot of time and try different things and so on and so forth. But we did like it took us in total, I think, the first 1 month to develop the first minimal MVP, and then to scale it and make it robust. I think we took 4 to 5 months on top of that. And I believe there is a better way to do this and to develop this solution. And that's I thought about, that's I basically doing the research and being involved in the topic. I thought, okay, if we had this digital twin of this manufacturing from the first place, and then we can simulate different processes and different technologies and iterate those different designs and different algorithms in early stages on simulation. And this can accelerate the development. Like basically what we done, like we didn't even have a digital twin for this process at the time. So basically for each iteration, for each new design we needed to test it in reality.
Hmm.
And testing in reality means you have to set up everything, you have to be in place, you have to, like, calibration was also a big topic. Basically we need to calibrate, so we need to do calibration every then and there. And we some problems happened and we need to solve them. And and it is damaged. Sometimes some of the problems damage some parts, so we need to reproduce those parts. And imagine we did everything, like do this from early stages. We have digital twin of the manufacturer, so we need what we need to do, and we started designing. You choosing different robots and designing different grippers. If I changing the design in the gripper, see how it interacts with the parts, and so on and so forth, and do those iteration cycles on the simulation. So this is one of the biggest advantage of using simulation and digital twin in development space. And if I move forward, um, another thing in the direction of digital twin, another thing is talking about development AI systems. So now we're going in the robotic spaces. We're like a new topic being opened, is that we're going away from those if-then way of programming solutions, and we want to develop AI systems that are capable to interact and do the specific tasks.
Or
And for
I
those,
have a comment, sorry, because I
sure.
think AI would be the next topic. Before going to AI, I have some
Okay.
questions. So basically, you mentioned that like you had problem with online programming basically to be there, and if you could to do offline programming in a way that everything was like somehow simulated before really applying that on the factory floor, that would be quite easier or make the job feasible. So um, what exactly do you mean by simulation? Like because
Mhm.
what is the difference? Okay, this is the question. What is the difference between an offline programming simulation with a digital twin? This is something that sometimes also ask myself what is different here, because I know that in digital twin everything that moves, every dynamic that moves needs to be somehow translated in the digital twin. So I would imagine like a physical world, and I would imagine a digital world. So anything that moves here, anything that has a dynamic, should be somehow in digital worlds a representative, or as a representative to be digitalized. And that's not something easy, because of course you can apply a lot of tools to somehow simulate the motion, for example, if it is a package or anything that moves on the conveyor. So you have to also think that how it could be represented in the digital twin world. So that's requires a lot of computational power to basically simulate every single possible element in the world. And that's something, it's a little bit different than just offline programming or the software that exists actually in the market. And that's why I'm a little bit cautious to name it as a digital twin, because there are lots of things involved. What's your opinion?
Yeah. Um, so I think the term digital twin, or I think there is also the term industrial metaverse or simulation. They can be used to describe different things. And I think like also different people can mean different things. So I'm saying it. And I think it's always, and also me as a person, I can use it for different meanings depending on the situation. So basically, like if we have data, if just have some numbers that describe the position of the robot, just numbers, I can also call this a digital twin. The digital twin doesn't have to be the 3D space with nice rendering
Mm-hmm.
and this nice power to call digital twin. Like if it's just like digital twin, it's just a digital representation of physical um,
Sure,
objects.
sure. It can also be.
So if I'm able to describe those objects using more simple way, and depending on the use case, it's actually a question that I also myself also ask my question, and I get challenged about this talking with my colleagues and the clients, is what is the value that brings me to bring this new other area of building digital twin. And that's why, yeah, for each use case, you have to always see, okay, how I want to model this digitally, and then to do exactly what you need. And so for our use case, for example, if I go back to this example, a digital twin of the problem would be, to simplify it, I just need to describe the environment where I'm gonna put the robot that it's gonna interact with in a way that I can test the processes. So I will probably need the conveyor where the parts are gonna be. They have to be in the correct uh, level, and the speed has to be the same speed as it is in reality. And yeah, and then I need those palettes with the parts. So for this, I can also design them in a way that reflect the reality. And also, this it's actually not a digital twin because like it's a digital representation, but it's not a live digital representation. So I just created it's similar to reality, and I start doing those tests on top of it. So it's not like live synchronized with the real factory because I don't need this for my development. My development, I just need to basically be able to describe the use, how the process is, and then I just use it. It's basically I simulate it, and I try building robots and try different movement of the robot just to simplify it, and like using simulation. So the process is not is not reflecting in reality. I think then this only happens at the end step of the development when I'm confident with my design, and yeah, and then bring it. I start producing this what I have in digitally in reality. So yeah, this is just a use case that I have now. How I described. I think we can we can have different, like for another example would be when I'm doing I want to monitor the process is already running, so I deployed it, it's already running, and I want to monitor it. And maybe it's a dangerous area there. I don't want to be there to see how it is working. And then there it's helpful to have a digital representation of my process of my factory that I can control it and see how things are going are doing. And there I also will meet with the client and think, okay, what are the data that I need to to monitor this process? And then we build the sensors required for that data, and then I just focus on that I'm needing. In some cases, they are just numbers. In other cases, you may need those 3D representation. And yeah, that's
That's basically
basically
the
it.
general
Mm-hmm.
concept, right? Because almost almost 20 years that this offline programming tools actually exist, and of course this word or term as digital twin is not for a long time that was used. So it's a kind of a new concept, I would say. But I think the creator of this word digital twin had somehow a little bit how to say another, or let's say a bigger dream for digital twins. So exactly that you mentioned, that like a live synchronization of everything is happening on the factory floor to be somehow simulated in the digital world. And that is something crazy because as I said, it needs a lot of computational power to simulate everything that is happening on the factory floor, because the idea was that either this way or that way. So imagine that you have an avatar. All right, so imagine that you have an avatar and you go in this digital twin world, like a digital version, and a humanoid robot represents you in the factory floor. So it is both ways. So it is like that you say that in digital world I have an avatar, and in real world I have a humanoid robot that do the job, or the other way around. If anything happened in the real world, there should be a representative of that in the digital world. Somehow synchronize everything. Of course, it's as I said, maybe exaggeration, but I think the goal of this idea is that somehow to make it everything synchronized in that in this way. You know what I mean? And
Yes.
that's something that maybe at the moment there is no really application for that, but in the future factories, that's something that they want to achieve in order to minimize the production time maybe or cycle or anything to be happen to be monitored at that time. So this is my understanding of the word digital twin.
Yeah. To be honest, like here, I'm also seeing a trend that we sometimes see those use cases where companies say, "Hey, I have a digital twin of the whole factory, of all my factories," but this is very, very, very rare cases. I think what is now existing is smaller proof of concept of smaller use cases where people try to build digital twin out of them. But we're gonna come to the like something to keep in mind also, Nima, is that those computation power is expensive now, but it's getting cheaper quickly. So like those like we a lot of intelligent people are working how to make those processes more efficient, to consume less energy, and to make them cheaper in the long run. And I think the future, how I see it, is we need some, we need to have all the data that we can grasp on. Okay, now we're focusing on only the data that we need. But I think the tendency is that we really have this digital, like as you described it, everything that moves in the factory, I have a digital league. And this will open a lot of doors because, of course, like in the future, are gonna be working with AI systems, and the more data those AI systems have, the more they're gonna understand the reality, and the more they can predict things or do better decisions, and and better understand. Yeah, like also um, yeah, I think it's a new topic. We can talk about it when we talk about the AI topic. But coming back, I think also I think we were mixing the topic, the word digital twin and simulation,
Yeah.
and I actually see them as two topics. So and how I see it is also we try to build this digital twin and just to describe it of one simple process with one specific way, be it like normal values data or 3D space of one process or of the whole factory. So we have this digital twin that runs with it. And whenever I need a simulation, whenever I need to do prediction, for example, when I need to make decision, I can just take this digital twin, copy it, and run this different scenarios. Like let's say I want to test how my system will react to different scenarios, and then I run a lot of simulations while my digital twin is running with the reality.
Mm-hmm.
So this is a parallel process that has nothing to do with reality. I do different
Mm-hmm.
scenarios. I do some adjustment in the manufacturing process. I add new robots. I do some complication in the supply chain that parts are missing or something like this, and I take decisions, and then I go back to the digital twin and I interact then with the digital twin, which is basically interacting with the reality. So this is how I see it. So I have the digital twin always running with the reality, and sometimes I simulate it. I
Sure.
use this digital twin to build. And also when I talk about simulation, when we like more in the robotic, we also a lot of time need the physics
Sure.
simulation. So when I need when I'm grasping a part, and I don't have enough friction, I want to be able to simulate
Like
this in
it
order to
feels.
predict
Yeah.
that.
Exactly. Mm-hmm.
And this is something sometimes you need and sometimes you don't need. Sometimes I'm just simulating to predict the speed of my process. So I have different machines that are working together, and I want the process to be synchronized. So I need to choose the speed that to put in the mid the robot in the specific machines, and then I can just simulate different speeds, different processes, and see the best, the more productive process to choose. So those are also different simulations, but they are both called
Yeah.
simulations.
Sure.
And this is always different depending on the use case. But this thing of having a digital twin, a simulation where you just do different testing or to data generation to build an AI model that you use it in reality. This is how I see it at least.
All right. Yeah. Nice. Um, I guess we go to the To the fourth part, I would like to know about the AI. We were mentioning about the application of AI or generative AI in digital twinning. What is the benefit of that? What is exactly does it mean, AI in digital twin?
Yeah. Talk to digital twin and those simulation, I think three topics where I see it offer a lot of advantages. So the first one, I think we already talked about it, is about this engineering and supporting life of engineers to offer them this environment to testing and improve the processes. And the second thing, I think we don't have to talk a lot about it, but it is about creating a virtual space where people can collaborate. So the engineers developing the solutions can collaborate together in this digital space. I think so I can work together with experts from all over the world in this digital space, and I can include them in the design process. I don't have need the expert to be in place. And the third point is to use the simulation of digital twin to to generate data to train AI models. So what we learned, I think a lot of developing an AI model, you need to have a lot of data of what your use case.
Mm-hmm.
And most of the time you don't have this data available, or you have only a little bit of it. And one way of augmenting the data or maybe generate completely new data is to use a simulation. And what we saw lately is that the rendering, like the quality of the, like talking about computer vision, for example, no? So I need to develop computer vision model that can detect quality issues or can detect the presence of a part and location of a part in the factory or in the pallet. And in order to develop those computer vision model, I need a lot of data of that specific area. So I can use this digital twin to um, to generate different scenarios of, like, basically I have this part that I need to detect. So I put it in different location and try different lighting, try different dirt conditions on the part. And the advantage of using simulation is that those data is going to be labeled instantly. So when you generate those data, it's already going to have like the bounding box around the part if I want to detect it, or the how far it is from my camera. Those data are already connected to the images that I'm connecting, and I can generate those data to train my AI model for computer vision. But the same principle, like now I'm very excited about this field. It's called robot learning, and basically is to develop, or also reinforcement learning is to teach the robot to, like, the movement of the robot are going to be controlled from an AI system. And and for that, we also need a lot of data, and I can use the simulation to generate different environments and to simulate different movement of the robots and see for each time how it is interacting, and then I can multiply a lot, generate a lot of data to train those models. But this is yeah, very interesting areas where yeah,
Sure,
the
it's an expensive area, I would say, because I really I recently read something on an article that a startup in US had got about 500 million euro, dollar fund for just simulating the robots, exactly what you said, that to train the robots using simulation tools to capable them for different tasks. So they know that now that the simulation is one important part of just teaching the robots to do some specific tasks, especially on the factory floor or anything like that is intended basically for the robots. So absolutely, that's very important that you have this capability to, like, I think that it's the lowest cost, or in a way that is the fastest way to teach robots to learn how to do the job by simulating. The other way, you cannot really teach a job, teach a robot just live on the factory floor to do things so easily that you can do on the simulation platform. So absolutely, that's a very important things for reinforcement learning, as you mentioned.
yeah.
Um, yeah, please go on.
And actually, at the end you need combination of both, huh? So you need to, I don't know, we don't have the numbers now, but I think you produce like as much as you can from reality, and you use this data to create a better simulation, and then you create millions of data in the simulation, and then you have basically this like you didn't start from the simulation from scratch. You have this this data coming from real environment, and then you use the simulation um, for data augmentation, we call it. So we multiply the data infinitely, and and regarding about this topic, lately, like one of the NVIDIA teams, it's called Groot. I shared about it lately. Um, basically, this is the pipeline that they are developing. So we need to develop, like in order to develop a robot that does certain things, we first do teleoperation. So human is guiding the robot how to do one task. We generate some data, and then we use simulation to augment this data. And then we train our model, and then we test it, and then we deploy it. And I think a lot of companies are already following
This trend.
this approach
Yeah,
of for data. Um, but going back to AI, I think something all the people in the robot, I think everywhere were exciting about when we had this ChatGPT moment and those generative AI, and I think, wow, this model have quite good common sense understanding of things, and they can generalize quite well. So a lot of people have been working on combining robotic with generative AI. So you have, and then specifically now, like we have models that can understand images. Step by step, we're getting models that can understand videos, and you have to keep in mind that those models are gonna get better and better. And so basically, you take your input from a camera, for example, is mounted on the robot. You give it more context, like a user describing what needs to be done, and you give it to one of those language large models, and then it can it helps support you taking decision for your robots, and a lot of people are also working about using those models to generate robot actions now. So like you can there are two approaches. Two approaches. Like people, you can directly use a large language model and you teach it, please generate the robot actions in this specific format that you directly can basically send them as an API to your robot that the robot directly move. But also from the research, they think there is now the talk about vision language action models. So we have those action on top. So the neural network directly predict the actions that the robot needs to do. And this is also a very interesting topic that I'm passionate about. I sadly have limited time to go into it, but I think this tendency about having the robot seeing, taking decisions, and moving directly, so taking action. So we have vision in, action out, and this is also an interesting field. So those models
yes.
are getting more capable and more capable, and now they are taking actions and interacting with our physical world. And I think this will, it's opening a lot of opportunities, a lot of possibilities to make the robots more adaptable, and more intelligent, as I described in the beginning.
Sure. If you remember at the beginning, we talked about that loss of a lot of jobs in the automation field. But I think now there's a big chance for people who are being replaced by robots or will be replaced by robots to come to this area and do simulation because a lot of it takes tremendous efforts to basically teach robots to do what they should do. So that would be nice if people just move to this area of simulation and teach the robot how to do the job basically instead of them to do, because this also needs a lot of energy to or takes a lot of
Yeah.
energy and time to
Yes.
just make the AI available for the robots to make it available to learn for the robots. So this is
Yeah.
something also I could see as an advantage of this approach.
Yeah. I like on this idea, actually something I believe, I'm curious if it's gonna happen. Like I'm a big believer of this teleoperation. So we need to teach the robot to do things. So we need to teleoperate it, basically control it using controllers, and those controllers are also getting better and better. A lot of people are using VR glasses or XR glasses and then you can control the robot to move. And I believe once we have the hardware cheaper enough and powerful enough, a lot of companies are going to deploy those robots in a lot of places, like supermarket, for example. And a lot of the jobs are going to be to teleoperate those robots to do the tasks. So the same person doing the task now in the shop floor and in the supermarket or in the logistic place, they're gonna be teleoperating robots that are doing the same task. I think this is also gonna follow us for a while until we have enough data and until we learn how to use this data to train efficient enough and reliable enough models. And I think this is also gonna be a big market for some
Sure.
time.
I mean, that's also one part teleoperation, but what I'm talking about, we don't need really a physical robot to be outside, because if you have a simulation model, still you can teach the robot for different scenarios. So how do you behave in that specific scenario? So it needs somehow human knowledge or human sense to understand what should be done at that scenario or situation. So that's why I'm saying that many people can come to this field and just teach the robots in a visual like
Mhm.
simulation world to how to behave. That's why I saying that before we go in physical outside, we need to do everything in digital world and teach the robots as the digital icons to understand what is the situation, how they should behave, and then later when the hardware is ready or capable to apply all those things, not, of course we could apply all these scenarios on the real world.
Um, yes, and like hearing you talking. Actually, those like in the company, like at Accenture, we have a lot of clients are interested in using the digital twin to train the employees to do the task. So before the employee starts a new job, doing new task, we simulate the environment. So we don't like we're not talking about robots in this case. We're just talking about whatever process that we are doing. And the employee, before it starts its new job, it goes through training that are in this virtual space that he can do the task and get familiar with all the problems and all the steps that needs to be done before he goes and start with the job. So this is also interesting.
All right, so I think the next one topic would be your open source project. If you wanted also to talk about your open source project and what's your um, um, idea about that.
Yeah. Yeah, sure. That's something I'm very excited about it. So like this field is very interesting. So I'm active in the robotic space for some time, but I'm also working full time, and I also since this generative AI come to the game, a lot of new people are working on a lot of interesting research projects, and I started getting overwhelmed myself. So I always want to follow the newest, and I think this was quite overwhelming. So I thought, okay, one way of getting over this overwhelming is to get around people who are also active in the field so that we can share experience and so on and so forth. And at the same time, like I have all of those experience about how the field is moving at the moment. And so yeah, like basically toward simulation and toward collaboration, also something that I believe in is like solving the robotic problem, like getting to the point where robots can really do what we want them to do in a reliable thing and in a safe way. Like no one company can get there and no one person can get there. And we need to, as a humanity, get together and learn and sit and collaborate in order to advance the technology. And at the same time, uh, I believe that this technology needs to be available for everyone. Like so we as people need to learn like this technology are advancing and we need to always keep up to date and to be able to use the technology. Like I'm and they yeah and then this all those ideas came together and with some brainstorming of some colleagues of me we founded this initiative. It's a non-profit organization. It's called Open Robotic Metaverse, and we did a lot of iteration on it. And the main goal of Open Robotic Metaverse is to strengthen the collaboration between in the robotic community and to open space for professional enthusiasts, but also beginners to come together, share their projects, share their knowledge, learn from each other, and collaborate in this field. So yeah, and we do this in two ways. So first thing is we do local events and we bring people together and we encourage them to exchange. So we have those robotic meetup that we organize where we bring people, experts in their field, or also hobbyists who are doing nice project in their home. They want to share and people share about their projects. And then we have like exchange around and like, yeah, it's like nice atmosphere where people can share about their projects and learn from each other. And at the same time, we also um, are developing and actually maintaining encouraging developing this open source platform. It's called Open Robotic Metaverse, which is a 3D space reachable from a browser, so everyone with the browser can access it. And there we can see different projects about different robotic projects, basically about yeah, robots doing things, basically like interacting with objects, identifying things. And the vision, the bigger vision behind it is that we first it's going to be a platform where people can share their projects and find each other. So each project, of course, connected with people who are working on it. So I can connect with them or I can use it, copy it, and use it for my own projects like GitHub, but more
Mhm.
interactive. But at the same time, I hope we have more contributors in the future. I see it as a platform where people can just create their environment or their challenges and the platform or other people and are expert in field can support those people with a challenge to develop a solution for their own use cases. Let's say I have a kitchen, I have a table with objects on top of it, and I want just to I need a robot that helps me clean my kitchen. I just create a digital twin of my robot. Like I will support you with the platform to create this 3D space kitchen, and then you can yourself choose one of the robots available, put it there, and step by step program it to do this thing. Or other field will see your use case and say, hey, let me try to solve this, and I try to solve the problem directly for that. And of course, we encourage this open culture where we encourage people to talk with each other, encourage people to share their knowledge, and encourage people to share their projects code basically. So it's open source collaboration, and believing in that this area is going to be more about data and less about code.
Mhm.
So I believe that the platform can also be a place where people can, after I created my scenario, I put my robot, I can teleoperate the robot to do things, and then I collect those data of that use case that other people that are expert in the field in the first area, but hopefully it's gonna be more accessible for people from outside in the future that can use this data to train the model and have a model that can do this task. And yeah, and hopefully, yeah, this data sharing hopefully can help the community grow faster and help us learn more about this technology.
Very nice, actually. Where is this? I got curious to know actually if this meetup is around. I would definitely come and say hi.
Sounds good. So our next community meetup is on 23rd of October.
Mm.
Now we're based in Aachen, so we are hosted like have good connection with our university, RWTH Aachen. We are collaborating with research institutes here, so we have a lot of good connections with research institutes in Aachen that they come and share their projects. But I think we're gonna develop more and more collaborations in the future, but also companies here around. I don't know if you are around. How far is Aachen from you? Where are you based actually?
In Koblenz, basically, I'm based,
Koblenz.
so I think it should be not far away from 1 hour and a half. But yeah,
Sounds good. So
I
you
guess
should come by. Sounds
definitely.
good.
No, no. I like this type of events just to meet so like-minded people, and
Yeah.
um, definitely. So I would share this things if you have any the address or the event profile that our audience, if they are as well in Germany, they can also definitely come and visit probably your meetups groups and
Yes.
talk about these things openly. And of course, yeah, as well, if you want, you can also share this 3D space that you can access it via the browsers. And yeah, so it would be nice to integrate with other people as well. That's very nice things that you do actually for the robotic community. And so basically, you get support from university, or it is like more self. How can I say?
So first of all, like we encourage, like if you are in a different city and you find the idea cool and you want to participate and like you like the open culture and you want to exchange to encourage this exchange in your area, reach out. I think we can support you organizing such events and yeah, it sounds actually, yeah, I love seeing the robotic community come together. And I think the robotic community are quite are open people. I love this about the community. And, and this 3D space, yeah, I think this will be easier to access. I think we're still working on the MVP, minimal viable product. And yeah, I'm excited about where we are ready enough, but we're working open source, so everything, our progress can be followed on GitHub, and you can test it yourself. The first like the first versions you can run them already, but we're in the early stage, I think, and we're still on the way to go. And we're looking for contributors. So if you like the idea, and we want to support it or give feedback, early feedbacks are quite appreciated in order for us to know in which direction to go.
Yeah, absolutely.
Yeah, and so we started as a student initiative and we're still a student initiative. So we get support from the university, and I love Aachen. Like we have a lot of like the last few years there are a lot of organizations, but also people pushing, encouraging this entrepreneurial spirit in Aachen. And so we have a lot of those organizations that offer you as a student initiative. You get a location to do your meetings, and the location to get your gathering, to host those events. And yeah, and I think we got positive feedback for now from the research institutes we are in close relationship with. The people are appreciating the idea and the effort, and hopefully we get more supporters in the future. But yeah.
All right, that's very fascinating. I'm excited as well. Hopefully, if I make it, I will definitely take part in the next meetup. But if not, the next one. But all right, I guess that's very valuable things that you do. I like that idea, and definitely encourage people to visit and join you for the meetup. And I think we have now 5 minutes to hear your final words about AI, digital twin, open source community, and anything that comes to your mind.
Wow. Some, something that I'm seeing that it's quite exciting, that a lot of people, a lot of companies also worldwide are working on this on this topic of making robots more general and more capable, and at the same time cheaper. And this is big part of this is done from the open source community, and I love this. Like a lot of companies are also working open source, but a lot of individual people are contributing open source. And I think those are two topics. So basically the powerful and intelligent systems and the affordable systems. So I think this together are going to have a big impact on society. And I think the life and society how it is now are gonna have to go through radical or big change in the near future. Like we're not talking about 30 years anymore. We're talking about 5 to 10 years, and we have to prepare ourselves to adapt to those changes. And that's where I encourage people to get informed about the topic, to always learn and keep learning. Like, for example, they say, ChatGPT, what is this? How can I use it in my daily life? This is already starting. But once the robots get to this area, we have to interact with systems that interact with our physical space, which gonna have bigger impact in life. So they're gonna be there doing things. So
So
we need to learn that this is coming, understand that this is coming, and hopefully prepare to deal with it and don't be surprised and be able to adapt. And that's like why this one of the motivation to start up in robotic metaverse to start like to encourage people to share and to get more people involved
I
in
guess
this.
that you raise a very important question, especially about open source things, because I don't like specifically monopoly. When something gets, especially AI way, that is somehow in the future would be a huge effect or would have huge effect on the people's life. If it's gonna be a monopoly for some specific companies, that's something that it's a no go for me, because I know that how effective or how that's why I think the open source community should somehow really actively get involved in developing these data sets, these AI things, because if it's really going to the specific type people or specific companies, that's something that I don't see any positive outcome out of that. And yeah, so this is that the open source community should think about that. Something that is missing, especially in the AI by open source community, is the lack of computational power, because it's expensive. Of course, you can software, you can contribute from point of view, but the hardware is something that's not, it's not feasible for people like you or me and anyone that is interested to contribute, basically to provide something. um, I have heard, like for example, that Facebook announced that for its Llama AI, it will be open source. So Facebook or Meta probably have the hardware or computational power, and they are trying to make it open source. But that's a big obstacle in this way. So for open source community to contribute, what do you think about that?
Um, Yeah, so yeah, it's exciting to see also big players like Meta open sourcing their model. And by the way, it's already out there open source, and I think they lately published latest version, which is quite powerful, like quite capable, and and something exciting about it. Like they published a paper that is, I didn't see it myself, but it's 90 like or above 90 pages with a lot of details. So you can really see like the technique that are using, what like all the learnings they gather during those the development of those models, and this is out there. Everyone can read it and see what those big companies can do. And at the same time, regarding those access, I think this is a big problem. Like those that the training of those models is expensive. You need hardware for it, but at the same time, um, keep in mind, hopefully, like those are getting cheaper. And people like if I see people, big companies like Meta open sourcing their models, and at the same time there are smaller companies like Hugging Face, which I'm a big fan of. Like they started like if you I think you can apply or you can tell that you are working on this project and you need to train their model. They even give you access to their GPUs to train your
Oh
model.
wow.
Um, it's really exciting, and I think this is gonna be more yeah, step by step. People are gonna understand that we need to collaborate on this and work together, and hopefully people or companies with money make those things available. And I think the government will come at a certain point, and universities, for example, they're gonna make like those clusters available for their students, and hopefully government will make it available for more people. But everyone is careful with those things, of course, because uh, everyone's saying it can be dangerous, and so the cost, like, okay, is it worth it now to invest that much money? But yeah, I think you just have to trust in the people that more people are gonna be more open and more engaging, and I think this is happening, and and then by the way, those this I saw people running those open source models, like for example the Llama you mentioned, on a phone or on a laptop, and it's like and this is also the tendency it's also gonna open a lot of doors. Like once those models that now only available through this platform that on the cloud now, it's gonna getting more and more powerful, but smaller models that run locally on our system, on our computer. And also this tendency um, that we see um, those like the focus is also going towards smaller, powerful models. So you train one model that is very specific to that one specific task, but it is very good in that task. I don't have much experience in the field, but I believe developing those smaller models is cheaper and it's gonna be also more accessible for people. So people will gonna be working on smaller models that are specific to them or
Affordable.
to their
Mm.
area. And also this is also gonna encourage us to collaborate more and share. And I
Sure.
give you, hey, I worked on this, and you give me your model that you worked in, and hopefully collaborate more as humans.
Sure. No, I guess that was very fruitful talk with you, Amin, and I really enjoyed our talk today. Hopefully, we'll do it again, and we will meet each other in real world, not physical, in yeah, digital world. But thank you so much for taking part and giving your time to us, and participating in this podcast. And if you do not have anything else, we can just say goodbye.
Thank you, Nima. I enjoyed the talk. Thank you for the invitation again, and yeah, looking forward for the next time then.
Sure.